So I wrote a book called Evidence of Evolution, which gives an overview of evolution and then focuses on evolutionary stories of specimens from the Academy. And I collaborated with a wonderful photographer, Susan Middleton, who took fantastically gorgeous photographs of specimens. And she's such a wonderful photographer that although every single thing in this book is dead, because it's a specimen, she really brings it to life. It's a beautiful book. So to research that book, I did a ton of library research, but I also interviewed the scientists at the Academy. So this was excellent. This was an excellent way for me to begin really writing about conservation, because the way to really understand nature is to start with evolution, because evolution is the big context for how nature works. And it basically has this enormously long history of the first life forms that came onto Earth and how those have changed, adapted, branched, gone extinct, and continued to move through time. And when I was struggling with how to tell the story of evolution so people could understand it, I realized that I needed to tell people about the process of evolution, like that molecular stuff, but also the patterns of evolution. And patterns of evolution occur in time and in place. So biogeography, which is the history of how plants and animals came to be where we find them today, is biogeography. And it's the overall context for evolution.
But what does that mean?
So you have a scientist at the Academy of Sciences, Bob Drews. He focuses on these teeny tiny islands, São Tomé and Príncipe, off the coast of Africa. These tiny islands have the most incredible assemblage or collection of plants and animals. They're found nowhere else. They're species found nowhere else on Earth. And they're also in relationship to each other in different ways. So a way to understand this is to go back to Charles Darwin taking his trip to the Galapagos. And Darwin comes upon the Galapagos and he notices that the plants and animals on these islands are very similar to the plants and animals he's just seen in Ecuador, but they're different. And he says, why is that so? But meanwhile, Darwin is entering the conversation of how plants and animals came to be where they are and what they are, you know, a couple hundred years into the conversation. So go back to the very beginning of the conversation and put it at Linnaeus. Linnaeus called himself a pastor of nature. And what he did is he created this vast cataloging, this organizational system for understanding plants and animals. And so he was looking at Noah's Ark. It starts with God. Linnaeus is looking at Noah's Ark and saying, okay, after the flood, so the plants and animals dispersed down from Turkey all over the rest of the world. That's what he thought. But then people start thinking about that. Well, how could plants and animals who can't swim get across oceans? How could plants and animals that could never survive life in a desert kind of show up on this side of the desert? So this is the thinking, like there's got to be a process to this pattern. The pattern and the process go together somehow. And this is what Darwin and Alfred Russel Wallace really kind of put a very big marker down and said that this process of natural selection, adaptation to environment, is what drives speciation, new species. So what you see is all these animals and plants are going extinct. We're cutting off this vast lineage going back millions of years, kind of willy-nilly, just because we want to build a shopping mart. And we've just reached a tipping point. We've reached a threshold.
One of the guys you talk about who, I think he was one of the creators of iNaturalist.
So you're talking about Kenichi Ueda, who, with two other students, they created this website called iNaturalist. And I heard about iNaturalist from Scott Laurie, who is now Kenichi's partner in iNaturalist. And I met Scott Laurie when I was working on The Spine of the Continent. It was kind of funny because I went to see the two lead scientists on this paper, Phil Duffy and Scott Laurie. So Phil, and he's a physicist, so he's telling me, you know, I did these numbers to come up with the velocity of climate change. And we had been talking about it in this group of scientists, like how fast is it happening? And is it happening at different rates in different kinds of climates, different kinds of elevations, and so forth? He said, so just for the fun of it, because that's what you do if you're a physicist, for the fun of it, you run like immense numbers to see what comes up. So he had run these numbers for the fun of it. And then he's telling me this story, and he says, and then I run into Scott Laurie, who I know from talking about these things, and I say, look what I did on my laptop. And Scott Laurie says, well, I did the same thing for the fun of it. Because he's also
one of those guys.
One of those guys. And they came up with the same numbers. And what was very apropos to the spine of the continent is that they showed that species in mountainous areas, there's all different kinds of climates and terrains in the mountains. And if you're a species on the south-facing slope of a mountain and you need to go somewhere cooler, you can just go maybe a few degrees onto a northerly slope, and you can get to a significantly cooler climate. So those species are going to survive a lot better probably than species that would have to try to move across a desert to get to a cooler temperature. So it's very important for this whole concept of where are the right places to protect nature, where is it most important. That's one of the reasons the spine of the continent is so important, is because in these Rocky Mountain ranges there are so many different kinds of habitats. So it's very important to save. They're going to be refugia as climate encroaches.
But now, so tell me, how do you go from that project to citizen scientist?
So when I was researching the spine of the continent, there's all kinds, one of the most bewildering things of, oh my God, how am I going to put my arms around this subject, is the world of conservation, because it's a moving target. There's little nonprofits, there's big nonprofits. So you've got your Nature Conservancy, your World Wildlife Fund, Conservation International, and they're all doing something, and they're approaching saving nature in different ways. You have government agencies, NASA satellites are taking data on these enormously big scales. So I'm like, what could work? What works? What could scale? Because even the Nature Conservancy can't buy up all the land. And even if they did, then it has to be managed by people who know what they're doing. And a couple of projects that I talk about in the spine of the continent were citizen science projects. They weren't called that. One was out with Mary O'Brien in the Utah forests, the Utah wilderness, where for something like 10 years now, she has taken out volunteer groups who have, and I was with her on one of these, measuring aspen, cottonwood, and willow browse. So we're out with measuring tapes. So what you're doing is you're measuring how big the piece of willow is that these cattle are browsing. So they call it the browse because that's where the cattle have been eating. And her whole passion in life is to get beaver reintroduced to the waterways of Utah. And the reason you want to do that is because when beaver are on the waterways, they retain water and create healthier habitats for all kinds of other species. So in a world where we're losing species and losing habitat, putting beaver back where they were historically can bring lots of species back. And it also, in a world that is going to have more fire and drought and big weather events, creates a more resilient landscape to both fire and drought. They're fascinating. In fact, I almost got into a fist fight with a scientist at the Academy who said, beaver aren't very interesting. What? Are you kidding? And this is fascinating though, because these are scientists that are looking at things under microscopes and they're mashing up DNA, and they think things are interesting because, you know, I don't know what. But a beaver, nobody has explained why or how. To me, this is the mystery of life. Okay, so fair enough, the beaver is not too smart. The beaver has the smallest brain relative to body size of any mammal. Okay, they're not smart. But what they do is profound, because by changing the geomorphology of the landscape.
What does that mean?
It means that they create a different way that the water and the land and the ground interact, creating habitat that allows all these other species to come in and live. Huh. So in a sense, beaver, I think I mentioned this in the spine of the continent, there's a Native American story, a creation story about how beaver created the world. And in this story, the world was all water. Beaver went all the way down and brought up mud, and brought mud up to the surface and created the first landform. Now in many ways, this is an accurate scientific way of looking at what beaver do. And they're rodents. They go way back. They've survived many ice ages, many extinctions. They're very, very resilient, and they regulate the environment. So this is without any thought to what they're doing. And once the beaver are gone from waterways, quite often those waterways degrade. They don't function in the same healthy way. The water moves too fast when it's not stopped by beaver dams. But then the tragedy that occurred to the western landscape is this massive insertion of cattle onto the landscape. Cows that we have are descended from an Asian bovine, and they are associated with water because there's a lot of water where they came from. They're put on a landscape where there's not a lot of water. And buffalo, buffalo could retain all that water like camels and also roam these huge trajectories, could go thousands of miles. And so what Mary O'Brien does is show the Forest Service in Utah that until the grazing practices are changed, she can't reintroduce beaver because there's no habitat for the beaver, because the cattle eat the willow all the way down to the ground. And the beaver needs willow to create their dams and to eat. So one main takeaway from the Spine of the Continent is we all have to be local and global at the same time. The environmental movement, it's been suggested by a lot of people that a good direction for it is something called bioregionalism, in which people understand and relate to their physical environment of where they actually live, kind of like Native Americans did. Really understanding what are the patterns of your place? What are the other creatures that live here with you? And the idea is that if you know something of the patterns of where you live and who else lives here with you, you'll take care of it better. But especially now, we need everybody to be involved with science, and there to be kind of a discussion going back and forth between people who have their PhDs and who have careers in science and other regular people who could have observations about patterns that they see that could be very, very interesting and useful to the scientists. And then the scientists can also tell people about their environment. At the same time, we have this need to really steward the land, really take care of our own backyards, and really taking care of where you live, that I really feel can make the biggest impact on, going forward in the right way.
Well, thank you for doing this.
Well, thank you.